Hello and welcome back to the MCAT grind. This will be a quick one. It's General Chemistry, Chapter 4, Compounds and Stoichiometry. Now, compound stoichiometry will come in discrete problems most of the time, asking you to determine the theoretical yield or the empirical formula, or balancing out the equation and finding that ratio on multiple choice. So it's easy points, but you have to be careful about balancing and making sure you're practicing enough. Now, starting off, we have a definition of what a mole is. A mole is just like 100, 1000, just a unit of measurement, and it's 6.022 times 10 to the 23. That is a huge number, and it can be used to define number of particles in a carbon-12 atom. That's perfectly 12 mu. Now, what it can also be used to denote is the molar mass. So 6.022 times 10 to the 23 of these certain atoms will give you a certain mass, and that mass is used to do calculations and perform all sorts of experimental conditions. So molar mass is what's indicated on the periodic table, and you can use that to refer to using your questions. Normality is the equivalent number of a certain compound. So in the case of hydrogen, normally if you have just a HCl, well, that's one hydrogen every HCl, right? But if it's a H2O2, for instance, that would be 2 hydrogens per every compound. So the normality of that will be 2. So what usually gets indicated is 1N of 1N, one normality of H2O2 solution would actually mean 1 m of concentration, or 0.5 m actually, because 0.5 m times 2 gives you 1 m, 1 mole of that concentration. Next, we have the reactions that you should be able to know very simply. Combustion reactions react a fuel with oxygen to oxidize and turn to carbon dioxide as well as water. And you have synthesis, which combines A plus B and gives you AB, just 2 compounds joining up together. Decomposition is the reverse of synthesis. Single replacement, one gets switched. Double replacements, both compounds switch with each other. Double replacement will come in very much in certain passages. They'll ask you to try to incorporate a certain condition, and usually that comes in the form of, well, what would be the theoretical yield from this given sample and the result. Now that brings us to yield. Just after this last one, neutralization is just acidic and a basic solution generating salt of some kind as well as water. Theoretical yield is used by the limiting reagent, so whichever compound gets used up the fastest, and using the amount you have to generate what the product is. So let's say you only have 1 cup of, you have 5 cups of flour at home, but you only have 1 or half a cup of sugar. Well, you're not going to use up all your flour, are you, to bake your cookies? You might only use 3 cups of flour to bake your cookies because you only have so much sugar, right? So that sugar will be your limiting reagent, or the amount that you need to actually make the product. So if you go over that, the product is just not going to be made properly, at least. So cooking is science. And we have empirical formula is just trying to simplify the compound into its smallest form. So that is A2B4 can be simplified into A1B2. That's the smallest I can go before I go into decimals. And since MCAT doesn't allow calculators, they'll commonly use eighths, like 0.166, 0.33, and so on. They'll use a lot of numbers to work with. So 0.125, 0.25, 0.375, 0.5, so on. Those eighths, commonly to make calculations a lot simpler and more clean. Alright, that's pretty much it for compounds and stoichiometry. This one's just practice and practice. Take care.